let me continue. So this one, equation 1 plus equation 2, then is MBG minus MAG equal MBA plus MAA. So if the mass of A and B are given, then you can solve and you can get what is the value of A. And this is the typical way to analyze question that is related to string or even spring. Try to take a look. Somehow, if I want to consider that the question that is not only involve vertical component. Example, if like this, there is a pulley here, there's an object here. Let's say object here, 2 kg. Similar to the previous question, but right now I put it such a way. And object B, let's say it never touched the edge of the table, which means no friction involved. Then object B 5.0 kg. And we make it further, there is a frictional force here, FFR. So I ask you to analyze this question and maybe you can give what is the acceleration of A. And logical thinking, you should know that object B is moving downward and object A is moving to the right. So in this case, let me proceed. For the object B, again, we consider downward is positive for object B. Then we can use, there is a tension here, upward, MBG downward. So MBG minus T equal MBA. On the other hand, for object A, we consider to the right is positive, then we may say that since there is a tension here, always away from the A, then we can say T minus FFR equal to MAA. And in this case, we further put it T minus mu. Let's say there's a movement, which means we need to use mu K. Fn equal MAA. Know it enough? Continue. T minus mu K. Fn for this case, if it's a horizontal movement like this, you should know that from previous example, the normal force is just simple mg. From that, again, equation 1, equation 2. Then equation 1 plus equation 2, you can calculate and get the answer. And basically, there is the effect of this one. So all the time, you can imagine that you must know that what is the final movement of the object, either A or B or both. Then, based on that, you try to find out the sigma F equal to MA or sigma F equal to 0. If I change this question, make it tougher a bit. It's still vertical like this, but there's an incline here, and this one, the string is stick to such a way, and this incline has a theta of 30 degrees. 30 degrees above the horizontal surface. So object A, 2.0 kg. Similarly, you still need to use, okay, for the object B, no problem. You still use MBG minus T equal MBA because no other thing involved. But for this case, you must think there's mg sine theta, the mg component that bring it down. On the other hand, there is another frictional force. Let's say the final movement of A is to the right. So for this case, we need to change it accordingly. Therefore, T minus mg sine theta minus mu kfn, which is actually FFR, equal to MA. And to make it clear, all the M we put it as MA. Then we continue. T minus MAG sine theta minus mu K. Yeah. What is Fn? If you still remember just now what I mentioned just now, Fn in this case is MA. MAG cos theta equal to MAA. So as a result, it becomes like this. So you can see that different case we have different solution, we have different equation, whereby all this we cannot consider is a formula. The only formula is sigma F equal to MA or sigma F equal to 0 if there is no movement or if the object moves at a constant speed. If the object moves at a constant A, we use this one. Maybe you will ask next, how about if nothing is constant, which means V is not constant, A also not constant, then we move to conservation of energy. I'll give you one example. Let's say a rod is fixed such a way. Maybe I change it, it's fixed such a way. So, due to the improper arrangement, let's say the object moves down, a little bit rotate down, and it becomes like this. It makes an angle, relative to the vertical component or vertical direction. So it asks maybe what is the speed or what is the, at this moment, what is the speed or what is the acceleration. And for this case, you know that different theta give you different A because the component keep changing. So this one is not a constant A. So I would encourage you for this kind of question, you use all these Newton's second law or the force to solve the equation. But I will encourage you to use conservation of energy, which is if there is no external work involved, you can say that delta P plus delta K equal to 0. And for that, you may refer to LO6, lecture 6, work and energy, to solve this kind of problem. So, one of the conditions to use all this formula is we know what is the V, we know what is the A, especially A, and this A is a constant. With that, then only you can solve, you can use the Newton's law to help you to solve the question. And that's all for this chapter. Thank you.